Hi, this is Neil here from the Dirt Floor Workshop. Today's video is about tungsten carbide inserts for the lathe, for turning in the lathe. Now, this subject is huge. The number of inserts, the different shapes of inserts, all the different grades, all the different chip breakers, all the different selection systems. It's a huge subject, so I'm not going to be able to cover anywhere near enough of that. So I'll just give you a bit of an overview. And what I'm going to start off with is when you buy a packet of inserts, it'll have a number on it, and that number will tell you a lot about the inserts. And in this case, these inserts I bought here, this is the number, and I've just written it down here, and I'll explain to you, I'll give you a bit of an explanation what it's about. Now the C is the first one, and in this case it stands for rhombic 80 degrees. And what we'll do is I'll just give you a bit of an idea what that's about. Now, as you can see, all these letters down here refer to a different shape, and these ones here, the rhombic one, we've got C, D, E, F, and they are all different degrees, and some of them are fairly simple, like T stands for triangular, S for square, and some of them are a little bit more difficult, like W for trigon. But you really need this chart if you're going to work out that. Now the second number, the second thing that comes up is the relief angle, and in this case it's 7 degrees. So if we look at the symbol, we go to C, we have a 7 degree. Now there it is down there. If the insert is got 90 degrees, it will have a 0. So that symbol will be N for negative. Most turning on the lathe is done with negative inserts. Not all of it, but a lot. And the way that works is your tool is actually running down like that, and the insert is at a negative angle. And when you're using an insert, a lot of times what you're doing is more akin to bulldozing than cutting. But because you've got a lot of horsepower and you've got a lot of revs, that's how you achieve good cutting. But some cutting, sometimes you need a positive insert, and in that case you need some sort of relief angle, and that second letter is about the relief angle. Now the next thing we can look at is this letter here. Now this one here refers to the accuracy of the insert, how accurate it is, so that if you change inserts, how much difference will there be in the new insert that you put on compared to the old insert. Well, a lot of times in a lot of these, the accuracy of 0.25 is so small that I'm not even going to worry about showing you that chart, because it's not going to concern most people. The fourth letter is all about the hole and the chip breaker. Now that chart here, I've included here, and in this case, on this one, we've got a T. So if we go down here to T, we find the insert that I've got is this one here, 40 to 60 degree with a countersunk, and it's a single-sided with the countersunk on the top and the chip breaker on the side. That insert that I've got, I'll just show you that insert. There it is there. You'll notice that it is rhombic shape, like it says here. It's a 7 degree, you can see the slight 7 degree angle there. It's a positive insert, and the hole, I'm not going to take it to pieces and show you, you'll just have to take my word for it, that those are the details there for the hole on this particular insert. Now, we move on. The next letter up here refers to the cutting edge length. Now, this nomenclature that I've got on these inserts is ISO standard. It's not American. So the American system uses a slightly different system for working out the cutting length or cutting edges, but this is the international system, and this 09 means that that's 9 millimeters long. So if we have a look at that, we can see that refers to that length there, 9 millimeters. The next thing is the thickness of the insert. Well, it's a complicated sort of a system where it started off in imperial and then it moved to metric and then somewhere along the line. So the actual thickness of that insert is 3.97, but that information there gives you the thickness of the insert. The next thing is the corner radius. On this particular insert, it's 0.04 of a millimeter. So we can see that is a pretty sharp sort of a corner radius there. Anyway, we move on. The next thing is these letters here. These letters here will not be the same on from every manufacturer. That is a particular. This insert is actually a Kyocera. I'm not doing advertisements for Kyocera, but this insert is a Kyocera insert, and that is their own code. This chip breaker here, this information here refers to the chip breaker, and I haven't got a chart to show you that. This information here is also proprietary for Kyocera, and that refers to the grade. And this information over here is more about the shape of the type of insert and stuff like that. Anyway, that sort of gives you a quick idea gives you a bit of a rough idea how to choose an insert. But choosing an insert is a very, very difficult. It's a very difficult sort of a thing to do. And if you just go along to an engineering supply company, what they're probably going to do is they're probably just going to have a lot of inserts which are sort of average, middle of the road. But if you've got a specific task that you want to achieve, you really need to sort of work out whether that's the right insert for you. Now, I solve the problem by talking to I just ring up a mate of mine, Cosmo, who's down in Sydney, and he's been in the insert business for 40 plus years. So I just ask him, and he tells me what I need. But for the rest of you, you probably can ask AI, or maybe you could download the manufacturer's catalogue, and it might have a selection system in it. But I'll just talk a little bit about why I wanted to choose this insert. I was talking to a mate of mine who's got he inherited a Hercus lathe from his old man, and he said to me, "What sort of inserts would I need?" And I said, "Look, I don't think that you can use an insert on an old lathe like that, because they turn too slow, and they haven't got the horsepower. Those old lathes were 80 years ago when that was made. They didn't have tungsten inserts, or well, they might have had them, but they weren't commonly available. What happened was that the blacksmith would get a bit of carbon steel and bash it into shape, and then they'd heat treat it and grind it, and that's what they used for turning on a lathe." And so I said to him, I don't think you can find an insert. Anyway, I'll do a bit of research and see what I can find. Anyway, I rang my mate Cosmo, and he said, "Yeah, sure." He said they make inserts for old lathes that turn slow, and just straight off the top of his head, he sent me this one. And that's why you need to know a little bit more. If you're trying to do something a little bit special, that's why you need to know a little bit about what you're doing, other than just walk into the shop and say, "Have you got an insert?" Or maybe you could just go online and make a choice that's wrong. Anyway, what else can I tell you? This is a bit of a drawing of a negative insert, and it just shows you how I'm just showing you how you don't need a relief, because when the insert is down like that, it's cutting on that point out there, so it doesn't need a relief. And a lot of the modern lathes with high horsepowers, that's how they do it. But if you're on an old lathe, you probably need a positive insert, and that's why this one here is a positive insert, because we know it's positive because we've got 7 degrees of relief. The other thing that they used to use in the old days was they used a tool like this, where they could just undo this and just grind the end of the tool and keep bringing it up to the center height. Now, the problem with tool steel, you can use tool steel, of course, but the problem with tool steel is when you cut a bit of a positive rake on it, that's fine until it wears out, and then to sharpen it, you have to cut down here like this. And that's fine also, but then it's no longer on the center height, so you've got to pack it up. You're continually putting pieces of packer in there. As you go further and further down, you have to keep putting more and more packer in there. Eventually, you get to the point where that is useless, and then you have to grind all that off and start again. So, tool steel is a good way to good for old lathes. But you know, you've got to have a bit of patience and a bit of skill. Anyway,
can we have the email address one more time, please?
I think you've seen it.
Thank you very much. Thank you.
Anyway, I've talked enough, and thanks for watching. Bye.